Okay, so we're at it again. The last video was about the mutually exclusive events, where one event has nothing to do with each other, the other, because the what happens with the picking a four has nothing to do with picking a face card. They have nothing in common. They have no overlap at all whatsoever, so they don't affect each other. So those are mutually exclusive events. If it's a four, it can't be a face card. And if it's a face card, it can't be a four. So we continue. What's the title up top? Let me get my faithful pencil here. Um, there we go. Okay, yeah. So now our title is addition rules. We're continuing with that. Addition rules. Oh, 1 second. Here we go. Addition rules of what happened here? Yeah, addition rules of probability. Okay, we did one addition rule with the mutually exclusive events. Here comes the next one. So what happened before, right? In the previous video, we had a formula which was the probability of A union B, which A was the 4 in that case, and B was picking a face card, is equal to probability of A plus the probability of B, and that was mutually exclusive events. Mutually exclusive events. Okay, now let me give you a problem over here called problem number 1 for today, I guess, for this video. Problem number 1. Here's the question. You pick a card at random from a deck, and the question is, what's the probability that it is a king or a red card? Now, don't forget what red cards are. Red cards are all of the diamonds and all of the hearts. So it's either a king or a red card. Okay, now be very careful. Let's first figure out what the probability of picking a king is. Okay, let's first figure out let's call this scrap paper, so to speak. Scrap paper, and what's the probability of picking a king? Okay, there's 4 kings in the deck out of 52, so it's 1 out of 13. Right? There's only 4 kings in a deck. There's the king of hearts, the king of diamonds, the king of spades, the king of clubs. Okay, next part of our scrap paper is, what's the probability of picking a red card? The answer is, there are half the deck is red, half is black. So 26 out of 52 chances of picking a red card. That's equal to 1/2. Now, I don't care about the reducing right now. It's not nothing to do with the final answer, so I don't care about reducing here, but I'm putting the reducing, but I can leave the 26 over 52 for the moment and the 4 over 52 for the moment. Okay, so that means that probability of, if we call, let's say we call picking a king, we're going to call A, is going to be A, and picking a red card is going to be called B. Picking a red card is going to be called B. Sorry about that. Yeah. Okay. So the probability of A is equal to 1 over 13. 1 over is equal to, is equal to 4 over 52. I don't care about the 1 over 13. The probability of B, that's red, is equal to 26 over 52. What's our question? Our question is, what's the probability, picking a card, what's the probability of picking a king or a red? That's our question. So our question is, what's the probability of picking A or B? King or red? A or B? So it's going to be equal to probability of A plus the probability of B, but be careful, that would be 4 over 52 plus 26 over 52, but there's a problem here. We've counted, we've counted, when you have all the red cards, we've counted the kings. These are the kings. 4 out of 52 are kings, and 26 out of 52 are red. But we've counted kings in here. So we have to take out the 2 kings that we've already counted. The probability of in other words, the king of hearts and the king of diamonds cannot be counted twice. We counted them over here. You can't count them twice. So we're going to have to subtract something. So here is what we have to subtract. We have to subtract the probability of A and B. What's the probability of getting it being a red card and a king at the same time? It's 2 out of 52. There are 2 cards that are both red and 52. That is going to be the final answer. 30 minus 2, which is 28 over 52. And when we reduce it, the answer is, divided by 4, it's going to be 7 over 13 is the final answer. So that is when we're talking about, because picking a king and picking red these are not mutually exclusive events, because a king can be red. So they are not mutually exclusive events. Mutually exclusive events. And here is the formula for not mutually exclusive events. This is the formula up here, is the formula for mutually exclusive events. For mutually exclusive events. And here's the formula for not mutually exclusive events. Okay, let me throw another problem at you based on this. Okay, we've got a little bit of room to work with. Problem number 2. Intro. Doubles of dice. Double of dice are 1 1, 2 2, 3 3. You get the picture. When you throw doubles, is because the two dice match, the red one and the blue one. The red one, they're the same number. So here comes the question. What if we're asked as follows? What is the probability of, when your 2 dice are thrown, 2 dice thrown, and what is the probability of getting a doubles or a sum of 6? Okay. How do you get a 6? You can get a 6 with a 1 5, a 5 1. You can get a 6 with a 2 4, a 4 2, and you can get a 6 with a 3 3. And doubles, you can get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So what's the probability of getting a doubles or a sum of 6? The probability of getting, let's call this a D, and let's call this an S. The probability of getting a D or an S is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 out of 36. 5 out of 36. Plus 1, 2, 3, 4, 5, 6. 6 out of 36. But we can't count this twice. This cannot be counted twice. So how do you get doubles and a 6 with a 3, 3? That's the probability of D and S. Doubles and 6 at the same time. So we have to subtract minus, well, there's one way of getting 6 and doubles at the same time, 3 over 3. We have to subtract 1 out of there. And the answer is going to be 10 over 36. When you reduce it, you get, it's not 10 over 36, but the final answer is going to be, you divide by 2 and you get 5 over 18. So the final answer is 5 over 18. And there we go. And that ends this video. It's a little bit cluttered, but that tells you the full story of mutually events and not mutually events. So let's exit this. Let's exit.